All right, let's do this. Today, we are going deep inside a real GCSE exam question. We're going to take it, we're going to tear it apart, and look at the official mark scheme to figure out exactly what you need to write to get every single mark.
I mean, it's the one thing everyone asks, right? You can know all the science in the world, but how do you actually get that down on paper in a way that scores points? Well, today, we're pulling back the curtain. We're going to show you the exact, no fluff answers that examiners are literally trained to look for.
So, our focus is question 8 from an AQA paper. It's an absolute classic on rates of reaction. It's got a bit of everything, explaining an experiment, plotting a graph, and even a gnarly calculation. It is the perfect workout for our exam technique.
Okay, first things first, let's get our heads around the experiment that the question is all about. So, here's the setup. A student is reacting magnesium carbonate with hydrochloric acid. They're doing it in a flask that's sitting on a balance, and they're just recording how much mass is lost over time. Super simple, but this little setup is the key to everything that's coming next.
Right, let's get into the first part of the question, 8.1. This is your classic 2-mark explain why kind of question.
Okay, have a think. Why is the mass reading on the balance going down? You need to think about the products of this reaction. What is being made that can actually leave the flask? Remember, 2 marks means they are looking for 2 clear, distinct points.
And there you go. Look how straightforward that is. The mark scheme is crystal clear. 1 mark for saying a gas is produced, and the second mark for saying that gas escapes. That's it. No long, complicated sentences needed. Just be direct.
And here's a little pro tip, straight from the mark scheme. You can also get that first mark by being more specific. If you know that the gas is carbon dioxide, which it is in this reaction, and you write that down, you get the mark. So if you're sure about the chemistry, show it off.
Okay, let's move on to the next section, question 8.2. This is all about your practical skills, and it's worth 3 marks. It's time to plot a graph.
So here's the data they give you for the experiment run at 30 degrees. You've got 8 points to plot. Your only job is to get these from the table and onto the graph as accurately as you possibly can.
And this is your canvas. The good news is the axes are already labeled and scaled for you, so you don't need to worry about any of that. Your mission is just accurate plotting and drawing a really good line of best fit.
So, where do the 3 marks come from? Well, you get a whopping 2 marks just for plotting all 8 points correctly. And by correctly, they mean within half a tiny square. Then you get that final, crucial mark for drawing a single, smooth curve of best fit. And this is what perfection looks like. The points are marked with small, neat crosses. And look at that line. It's a beautiful, smooth curve. The key thing to notice is that it doesn't just connect the dots like a zigzag. No, it's a curve that flows through the points, showing the general trend. That's how you nail that 3rd mark. All right, now for the grand finale of this question, and it's a big one. This is a 4-mark calculation. You have to work out the rate of reaction from a completely different graph. This is where you can really show what you're made of. So the exam paper actually gives you this completed graph. This one shows the same experiment, but this time it was done at a hotter temperature, 50 degrees. You don't have to plot this one, but you are going to have to use it. And here's the task. Find the rate of reaction exactly at the point where 0.95 grams of mass have been lost and pay attention to the end of the question. Give your answer to 2 significant figures. So many people lose a mark because they miss instructions like that. Don't be one of them.
So, how do you grab all 4 marks? It's a simple 4-step recipe. First, you draw a tangent to the curve at that 0.95 gram point. Second, you calculate the gradient of that tangent. Third, you get the right number from your calculation. And fourth, you round that number to 2 significant figures. 1 mark for each step, boom.
Now, this is absolutely crucial. This is what your working should look like, right there on the graph itself. You find 0.95 on the y-axis, go across to the curve, and draw a perfectly straight line that just kisses the curve at that single point. That's your tangent. Then, and this is the pro move, you draw a massive triangle using your tangent. The bigger the triangle, the more accurate your gradient will be. You have to show this working to get the marks.
So once you've calculated your gradient, your change in y divided by your change in x, and rounded it, you should get an answer somewhere around 0.021 grams per second. Now don't panic if your answer is slightly different. The mark scheme allows a range because everyone's tangent will be slightly different. The important thing is that your calculation is correct for the tangent you drew, and that you've rounded it correctly.
Okay, let's pull all of that together. Just by breaking down this one question, we've basically uncovered a whole toolkit of exam techniques you can use on any question on any paper.
So here are the golden rules. Be precise with your language. Be neat with your graphs. Always, always show you're working, especially for gradients on a graph. And please, read the question carefully, for those little details, like how many significant figures to use. These little habits are what turn a good grade into a fantastic one.
And that's our masterclass done. You've now seen behind the scenes, you know exactly what examiners have on their checklist. The secret to success isn't just knowing the chemistry, it's about proving you know it. It's about communication. Now you've got the tools. You're ready to go get those marks.